Hello people. So joints or articulations are actually connections made between two bones. And at these sites, at these joints, they are allow different types of movements. And the joints in our body that are allow these movements are called synovial joints or diarthrosis. And diarthrosis means to separate, and it means that the bones are actually separated. So this is one synovial joint. Obviously, it's this picture is representing the hip joint. We have here the femur, and we have here the pelvis, or better to say, the acetabulum. The synovial joints in our body have this is the hip joint, but all our synovial joints have similar general structure, the similar components, and there are four main components every joint has, every synovial joint has, and all of these components are also present in some way in other joints in our body. So the first one that is very important is this blue that represents the hyaline articular cartilage. So in our synovial joints we have hyaline articular cartilage. Cartilage. And this cartilage is actually hyaline articular cartilage. And this is very important. Also in Latin, this is called cartilago articularis. Then we have obviously this cartilage lies on bone, and it is connected with connective tissue to the bone. And we have here is the acetabulum, and here is the head of the femur. And we see this is compact bone. Compact bone. And this inner is actually cancellous bone or spongy bone. The first important thing about in the general structure is obviously this cartilage, this hyaline cartilage. The second important structure is the joint capsule. So this is representing, this thin blue layer is representing the joint capsule. So the joint capsule is a structure that envelops the synovial joint. So this is the second important element that is similar in all synovial joints. The joint capsule. The third element that is present in these joints are ligaments. So the ligaments are tight, fibrous connective tissue that connects and strengthens the bond between two joints. So this would be a ligament. And that is the third important element. The fourth and last is this space in between the two bones. So these bones are also called diarthrosis in Latin, which means to separate, and they are separated by the joint space. So this is the fourth part of the structure. So these are the cartilage, the joint capsule, The ligaments and the joint space are the important elements of the joint. A fifth element that is also important, but that is produced by parts of the joint capsule, is actually the synovial fluid or the synovia. The synovia is present in the joint space. Now, we already talked about hyaline cartilage, and the important thing to remember about this cartilage is that this cartilage has no blood vessels. It is avascular, it has no perichondrium, and it is connected with connective tissue to the bone. So the capacity for renewal is not there. Only in children this cartilage can renew itself, but in adults a damage causes permanent damage that will not be renewed by other cartilage but by fibrous tissue. The second important element is the joint capsule. If we would take a part of the joint capsule and zoom into it, we would first see, for example, this is underlying bone. We would see that the joint capsule has two parts. The first part of the capsule is this outer part that is connected, for example, in this case, to bone with connective tissue. This outer part is called the outer or the fibrous layer. So the fibrous layer. So this is the fibrous layer or the outer layer. Or it's also called membrana fibrosa in Latin. This is basically, this outer layer is simple connective tissue with a few blood vessels, fibrocytes, and so on. But the important layer is this layer. This is the inner layer or the synovial layer. So the inner layer or the synovial layer. This layer is actually the secreting layer because it plays an important part in secreting synovial fluid. And synovial fluid is essential for synovial joints, obviously, as the name states. Now, if we would take only this part, so this inner layer, and if we would enlarge it further, we can now appreciate that it also has a compact structure. So the part that is oriented into the joint space, so here would be the joint space, has these cells, and the part that then we have, these cells are sitting on this sub part with that has extracellular matrix, blood vessels, a few adipocytes, fibrocytes, and other cells. So this inner synovial layer has actually also two parts. It can be further subdivided into two parts. This outer part that has many cells, and this part underneath, which has a lot of blood vessels and extracellular matrix. So if we would now, and we can see that this inner synovial layer has also some kind of villi that are projecting into the joint space. Now, we will enlarge this part of the cell layer. So this would be, if we enlarge this part, we can see it is represented here. It is the cellular layer. And if we enlarge this part, we will get this layer. So this cellular layer is actually called the synovial entima. So the synovial entima. And this part that is underneath, or this subpart, is called the synovial, logically subentima. In the synovial entima, we see that we have many cells. These cells are called A cells. All these cells are called synoviocytes. So, synoviocytes. So all of them are synoviocytes, and there are a few different types. We have the A synoviotype cell, then the B type, and cells that are not really differentiated, that are in between those two, are called AB cells. In the subentima, we have fibrocytes, but we also have these fenestrate capillaries. So this would be a capillary, a fenestrate capillary vessel, and this would be actually lymphatic capillary. So, and here would be the joint space. This is very important. So we came to the part that is essential for producing synovial fluid. The production of the synovial fluid represents the ultrafiltrate from plasma. So plasma that is in the blood vessel, so here, blood consists of plasma and cells. Plasma, when it is filtrated through these windows or fenestrae in the capillaries, it comes into the extracellular matrix of the synovial layer. Then these cells, for example B cells, that are also called F cells because they are similar to fibrocytes, they can produce hyaluronic acid, and they can also produce a protein called lubricin. So these proteins then also become part of this plasma filtrate, and all of them together, this fluid is being secreted into the joint space. And in the joint space, we have the formed synovial fluid. Or the synovia. The A cells, before I talk about the synovial fluid, the A cells are also called M cells because they have similar functions to macrophages. They can phagocytose different materials. And the AB cells are not really differentiated, and somewhere in between these A and B cells. So the synovial fluid is a fluid that looks like egg white. It has this egg white appearance, and maybe it is a little bit yellowish in color, but it actually is colorless. So it is egg white like, let's say it like that. Normally, in a joint space, there is less than 3.5 to 4 milliliters of fluid. So there is less than 3.5 milliliters of this fluid in our joints. So it is only a small amount that covers the whole cartilage and the whole joint, with a layer that is only 50 micrometers thick. The synovia is important because it has many functions that shield and protect our joints. First of all, it is important for reduction of friction. Secondly, the synovial fluid plays a part in shock absorption. Then, thirdly, the synovial fluid is transporting nutrients and waste. Nutrients are being transported into the, as it is filtrate of plasma, nutrients are being transported into the joint space, and that is the only reason why our cartilage, our synovial cartilage is surviving, because it has no blood vessels. The nutrients are coming from the synovial fluid. Also, everything that is waste is being taken up when the joint moves. The pressure is being produced, and then everything that is waste is going back. It is being filtrated into the lymph capillaries, and the lymph capillaries are actually taking up the waste products and eliminating them. So normally our synovial fluid also has a few cells, under 200 cells per in a cubic millimeter, and those are mostly mononuclear cells. In a joint effusion, so if you can see with your naked eye that the joint is effused, that you have edema in the joint, a clear asymmetry, you know that you have probably about 100 or a number from 50 to 200 milliliters of synovial fluid in the joint. And you can appreciate that you have joint effusion. The reasons can be many, but you need to know that normally only a small amount of synovial fluid is physiological, so 3.5 milliliters or less. If it comes to an effusion, you will, and you can see it with your eye, you have probably about 50 to 100 milliliters or more synovial fluid in the joint. The last principle is the clinical. There are many classifications of joints, but the important one that is commonly used is actually the clinical one. The clinical classification classifies joints on monoarticular joint pathology, then on oligoarticular joint pathology, and on polyarticular. If a disease is monoarticular, it means it only affects one joint. For example, gout is often only affecting the first metatarsophalangeal joint, so it is actually a monoarticular disease most of the time. Oligoarticular, for example, reactive arthritis, is affecting 2 to 4 joints. So 2 to 4 joints, so it is an oligoarticular disease. And for example, rheumatoid arthritis is affecting 5 or more joints, so it is a polyarticular disease in clinical presentation. This would be a simple overview of the important elements of our synovial joints. Thank you.